Yeah, hello everyone, and yeah, welcome to the session. Are you able to hear my voice? Uh, can anyone tell me? Mm, 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 mm.
Hello, Vishal. Good evening. Yes, we are able
Yeah,
to hear you.
good evening. So yeah, we'll discuss some of the questions from week 9, and yeah, I'll share my screen. You can join in from that joinpd.com, and then yeah, yeah. So you can join from this code. Yeah, everyone please join. Like we are having 55 participant until now, 8 student only joined. So I'll wait for 2 3 more minutes. Yeah, everybody please join from here. So one fourth, not one, only one third of the people has joined till now. So we are having 68 participant, only 22 students have joined. So yeah, I'll start now. So we have now 30 students who have joined out of 78. So the rest of you, why are you not joining? Is there any problem, or like are you having any issue from your side? Okay. Mm. So shall I start, or will you like, should I wait? Okay, still joining. Okay, join it fast. So 13th is your exam, right? So how is the preparation also going on? So are you able to hear me or not? Like nobody's.
Yes, yes, we are able to hear it.
So your like second quiz is on, I guess, 13th of March, right?
Yeah, it is on 13th of May.
Hmm.
It's up to week 8, right?
Yeah, up to week 8, and most of the portion will be from 5th to 8th week. So yeah. So when is the submission date for the ninth week, that assignment?
That is tomorrow.
Okay. Hmm. So now we are having 35 students. Okay, I'll start. So in between, if somebody wants to join, the code will be in the upper right portion of the screen.
Yeah, that we'll keep reminding in the chat. You may please start the session because everybody's time is also important.
Yeah, sure. So, okay. So we'll discuss some of the questions. Maybe that will help you out. And the first question is this one. Suppose that the number of customer reaching a particular shop in an hour time period follows a Poisson distribution with an unknown parameter lambda. Okay. And the previous record suggests that the prior probability of lambda are like you can yeah, like you can, what you can say, you can understand like there's a two bucket sort of things. One bucket is having lambda equals to 5, and the probability that I'm taking out the lambda from that bucket is zero point 0.4, and the second one is having lambda equals to 7, and the probability that I'm taking out the lambda from that bucket having lambda equals to 7 is zero point 0.6. So now if in a particular 1 hour time period 9 customer reach the shop, like some mistake here, reach the shop, now you have to find the posterior mod of the lambda. Okay, so yeah, this is the question. I'll give you some 10 minutes, you can solve this. Like this is a basic like concept of Bayesian estimation. You just have to see what's the likelihood function, what's the prior here. So you'll be able to do. Just you have to calculate for both lambda equals to 5 and lambda equals to 7 and check which is greater. Okay. So I'll wait for 10 minutes and then I'll start solving this. Till that time, if somebody has not joined, you can join. Like this is the code ODFOCY. You just have to go to the joinpd.com and then there you have to type this code and you'll be able to join. So you can see direct the question number first and then yeah. So I'll mute for some time and I'll wait for something. So till now only 7 people has responded. So I'll give you some hint. Like you just have to calculate the what you can say probability that lambda equals to 5 given what is the number of that customer. Yeah, x given x equals to 9. So you have to calculate probability of lambda equals to 5 given the number of customer equals to 9, and probability that lambda equals to 7 given x equals to 9, or you can say the number of customer equals 9. And then you have to compare which one is greater will be the posterior mode. So now you can solve, I guess. Just try it once. So 8 out of 42 has responded. 113 people are there. Why only 42 has joined? Rest of you can also join, and then I'll be getting a clear picture. The answer would be either 5 or 7. How come the answer will be less than 2? and greater than 10. Like, can you explain me whoever has given the answer less than 2? So out of 44, only 25 people, 26 has responded. The answer would be either 5 or 7. Majority of you are saying yeah. Can so okay. So I'll discuss now. So like whoever has given the answer apart from 5 and 7, can you say something regarding that? Like how you have marked the answer less than 2 or greater than 10? Like what was your point while solving this question? Can somebody respond or should I discuss? Okay, out of 125, only 28 people has responded. 45 have joined. Okay, then I'll discuss this problem. I'll write it down. So yeah. So yeah. So now we are having what? We have to just calculate what? I told you we have to calculate the probability that lambda equals to 5 given x equals to 9, right? This is what we have to calculate, correct? And you have to calculate probability lambda equals to 7 given x equals to 9, right? So I'll solve it here. So yeah, generally how like we calculate as we have to calculate the posterior thing, right? And this is what this generally we write the likelihood into the prior upon that normalization sort of thing. So here what is been given here, we have been given regarding the prior probability, right? The prior is what? Prior is we have the two bucket, you can say the lambda equals to 5 equals to what? The probability that lambda equals to 5 is 0.4 and the probability that lambda equals to 7 is what? 0.6. Here we have to calculate given the number of customer, right? That will be what? Probability that x equals to 9 given lambda equals to 5, product of probability that lambda equals to 5 upon probability of x equals to 9, right? Similarly, we can do it for that lambda equals to 7 given x equals to 9. Same thing, we have to write probability that x equals to 9 given lambda equals to 7. Product of probability that lambda equals to 7. Product of x equals to 9, right? And it's been given that it's a Poisson distribution. Okay. So for the Poisson, we can write the likelihood function where the x equals to 9 and lambda equals to 4, lambda equals to 5. How we can write it? So we can, how generally we write e to the power minus lambda, lambda to the power x upon x factorial, right? Because this we can't write because we don't have the lambda regarding this. Okay, but we have to compare the probability. We have to compare the value of this and this. Whichever will be greater, we'll take that as a posterior mode value, right? So if you'll just divide it, okay, or while dividing it also, whenever you will divide it, right? So if you'll divide it, this will be cut down, right? Because this will be in the numerator also and in the denominator also. So what will be left? Probability that x equals to 9 given lambda equals to 5 into the probability that lambda equals to 5 is what? 0.4 upon probability of x equals to 9 given lambda equals to 7 into 0.6. So you can write it like this: e to the power minus 5 lambda to the power 5 to the power 9, right, into 0.4 upon e to the power minus 7 into 7 to the power 9 into 0.6. That you have to see whether it's greater than 1 or less than 1. If it's greater than 1, then 5 will be the answer. If it's less than 1, then 7 will be the answer. So now you can check it. E to the power square 2 will go, and then we'll be having 5 to the power 9 upon 7 to the power 9, right, into 2 by 3. Okay, so upper one is probability that lambda equals to 5 given x equals to 9 upon probability that lambda equals to 7 given x equals to 9. If you'll check this, if I have to calculate 5 upon 9 is less than 1, and if this one will multiply it 9 times, so this will be very less, very less than 1. This value will be very less than 1. So if we'll multiply with e square also, that is around 2.7 also, this will be lesser than 1 only, because this is also less than 1. This is very less than 1, but this will not compensate that much that you will get greater than 0. Okay, so this is less than 1 means probability that lambda equals to 7 given x equals to 9 is greater than probability that lambda equals to 5 given x equals to 9. So what we have got, posterior mean we have got as lambda equals to 7, right? So the estimated value is 7. If we have been asked to calculate the posterior mean, so what you would have done for this question, we have not been given regarding the we can't calculate the probability of x equals to 9, but yeah, if we have been given this value also, we can calculate the probability, this one, we can calculate this one, and then we can multiply with 0.4 and then calculate the probability of this and multiply with 0.6. We'll get the mean value also. Okay, so mode is simply which one is greater will be the our posterior mode or the estimated posterior mode, right? So now we'll move to the second one. So we are having 147 student and only 46 has joined. I don't know why, and only 30 has responded. But
Sir,
yeah,
excuse me, sir. So, sir, in this question, couldn't we calculate probability x equals to 9 from the data given?
from the data given, how will you calculate that? Because for the what you can say distribution, we have not been given the lambda, right?
Yes, but but we have probability of lambda, so we can write probability n equal x equals to 9 as probability x equals to 9 given lambda equals to 5. times probability lambda equals 5.
Okay,
and
yeah. You can calculate that also.
we can calculate, right?
Yeah.
Okay.
So out of 148, only 47 has joined. Okay. So let's move to the next one, but once I'll check it. Most of you have given the correct answer, but yeah, many of you have, I guess, randomly written this value and this value. But yeah, whoever has written 5 and 7 is fine. Maybe there will be some mistakes, but some of you have written, I guess this is 14 and this is less than like 2. So this, I guess, we have just written randomly. But it's fine. Okay, we'll move to the second one. Yeah.
Sir, since it was given in the question that in a particular hour 9 customers visit the shop, wouldn't probability of x is equals to 9 be 1?
In a particular shop. Wait a second. No. The probability can't be 1.
But it's given, right?
See, in the Poisson distribution, in particular like interval of time, if like some sort of like if X number of student or X number of customer generally visit some sort of things, right? Wait a second. I guess I need to calculate, but what was the reasoning you were giving if in a particular 1 hour day 9%? So this is a one sample, right? Who was asking this question? Can you speak out once again?
Sir,
Yeah, this is a sample, like just for like it's a sample, like in an 1 hour randomly some sample has been taken out. In that sample we have taken seen that in that 1 hour 9 customer reach that shop. Are you getting my point? See, if you have to take x equals to 9, then the density would be what? It is about minus lambda to the power x. X is here 9, right? Upon 9 factorial,
yes, sir.
right? This would be the probability when x equals to 9. But for this, we don't have the lambda. He told lambda can be taken because we have the 2 lambda, right? So we can take the lambda as 0.5 and so lambda as 0.7. So from there, we can calculate the probability of x equals to 9. Right?
Okay, sir.
Yeah. Like we were having the distribution, some sort of distribution, like, and from that distribution, we have got some samples. In that sample, he has told ki in that like interval, whenever he has seen, there was 9 peoples. Right? So we can't say like for then so every time we will say okay, this is the sample, what's the probability that this will happen? The probability of happening this sample will be what? But we can't say that, right? Are you getting my point? Like we are having some sort of normal distribution. and we have taken out some sort of sample, and then we have told what is the probability that this sample will occur. But this sample has occurred this time only. That's why you are saying this probability of happening this as 1. But this maybe for the second time we are taking out the sample would be different, right? So the probability can't be 1 every time. Are you getting my point?
Yes, sir. Yes, sir.
Yeah.
Okay.
So yeah. So the next question. So here is the solution. You can go through that also. Yeah, this is the second one. So the call duration of daily stand-up meeting of an employee of a certain company follows the exponential distribution with an unknown parameter lambda. Okay. So again here, the population density is told it's a exponential distribution with unknown parameter that you have to estimate. Okay. But we are having some sort of samples also for 12 meetings, and this was the time duration. But we know that duration of time, or you can say the population duration, like the population distribution is in the form of exponential. But we have the samples of 15, I guess, 12 meeting. Okay, so 35 minutes, 30, 25, 15, 25, 20, 20, 28, 34, 30, 15, and 23. Find the Bayesian estimation. You have to estimate using the Bayesian concept. Okay, and you have been given the prior distribution already. That is exponential of 1 upon 20. So exponential of 1 upon 20 is what? 1 upon 20 lambda e to the power minus 1 upon 20, right? So if you are having any confusion here, so this is what 1 upon your prior distribution is 1 upon 20 e to the power minus lambda upon 20. Okay. So now try to solve this one. So everything I have told you. The prior distribution.
Can you repeat that again? The e power 1 by 20. I'm not able to get it, understand.
So that this prior distribution is exponential of 1 upon 20. That is 1 upon 20 e to the power minus 1 upon 20. So lambda e to the power minus 1 upon 20. This
Okay.
one. So this, I'll just write it once for 1 second, then you can see the question. So lambda e to the power minus lambda. That means 1 upon 20 e to the power minus 1 upon 20. Okay. Yeah. Now this is the question. Yeah, up to 2 decimal you have to write. Up to 2 decimal you need to write.
कोणती इन्स्टिट्यूट? हां 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 हां
Yeah, whoever has raised the hand can speak out. Somebody is asking something. Okay, fine. So if anybody is facing any problem, prior distribution, I've just written it somewhere. So I'll just write it. So this is the prior distribution. So this lambda. So here the prior distribution, wait for example.
हैप्पी बर्थडे टू यू केक से कह तो फिर खिलाओ जी काय नहीं है जी बत
This is the prior distribution. Rest everything is given here. So prior, if anybody is facing any problem writing prior distribution, this one upon 20 to the power minus lambda upon 20 is the prior distribution. Nowadays everything has been given. Now we have to estimate you have to use the Bayesian estimation to estimate the value of lambda. So none of you have given the correct answer till now. So try it out again. So here I'm giving, so prior distribution everybody is knowing now. So this is the prior distribution, and the likelihood also you'll be able to write as the likelihood. All this is coming from the exponential distribution, right? Are you guys able to follow up? Like, what is this answer? So you just have to write all the likelihood function. Like for the 35, you can write. So take the lambda, like lambda as the parameter for the exponential distribution. You have the likelihood you can write. And for that prior distribution also, you can just take lambda as the parameter and then write it like I have written. So this is the prior distribution. You have the, what you can say, the population distribution also has been given in the form of like exponential only. So you can take lambda as the parameter that you have to estimate. You just have to multiply this like in the and then you have to calculate. So if you'll just multiply this what you can say prior and the likelihood, you will get some sort of thing. Okay, this will converge to one distribution. From that distribution, you can calculate the mean value. So I'm telling you the thing also. This distribution, whenever you'll multiply the prior distribution with the likelihood, whatever you'll get some sort of gamma distribution. Now calculate the gamma, the alpha and beta of that gamma. Okay, and then you can directly calculate the mean. So now I have given you a lot of hint. Now you can try it. So what you have to do, prior distribution is when given. Okay, lambda is the, we can say parameter, and then you have the likelihood function. Likelihood you can write lambda e to the power minus lambda x. Okay, x has been given for 12 values. Multiply it, you'll get one gamma distribution. For that gamma, you have to calculate alpha beta. Alpha upon beta would be the mean value, the posterior mean. Okay, now you can try. And I need the correct answer. Till now, nobody has given the correct, like if some, what is the value nearby zero? Can somebody, whoever has given the response, can somebody tell?
0.04.
It's 0.043 approximately.
Okay. 0.043.
Yeah.
Yes.
It is 0.047.
Okay, it's yeah, nearby it's almost correct, but yeah, rest of you can try. I guess your answer is like point, the answer would be related to yeah, 0.4, I guess, 0.04, I guess. So rest of you can try it. Like I told you everything now. I just haven't done one thing only. I have not solved. Okay. Otherwise, I have told you everything related to this question. So I guess now you can solve it. So out of 167 people, only 50 has participated, and out of that 50, only 19 has responded. So okay, so 20 people, whoever has responded related, like I guess nearby zero would be correct. But whoever has given the answer related, like nearby 25 is totally incorrect. So yeah. So please try that this question. At least 60% people, if will give the response, then only I can move forward. Okay, now I'll solve this because, but most of you have not given the response. But okay, fine. I'll solve this one. So the prior function we already have. Okay. So that is 1 upon 20 e to the power minus lambda upon 20, right? And for the posterior, we can write it like this will be the likelihood how we can write. So lambda into the power minus lambda x1, right? Similarly, for all the 12 value, we have to write lambda into e to the power minus lambda x2. For all the 12 value, we'll be writing minus lambda x12, right? Multiplied with this prior distribution. So that is 1 upon 20 to the power minus lambda upon 20, right? So that will be what? So lambda will come 12 times into 1 upon 20, right? So this is a sort of constant that we can ignore. And then we'll be having e to the power minus lambda, and these all are in the product form. So we can just add this x1 plus x2 plus x3, right? And we can add it to what value? So this also will come here because x1 till x12 means all the values plus this plus 1 upon 12, 1 upon 20, right? Because this was also in the exponential, so this also got added, right? So this is what? This is some sort of gamma distribution. Are you getting my point? This is a gamma distribution, right?
Yes.
Yes.
So this is the form of what? Lambda to the power some value,
Alpha minus 1.
right? This is 12.
12
And this e to the power 9 is lambda that
plus
you have to do the
300.
summation. Plus 1 upon
300 plus 1 by 20.
this is 300, right?
Yeah.
Okay. This is 300 and 1 upon. So now we can write how generally we write in the gamma function. We generally, this is what? Alpha minus 1 and this is beta minus 1, right?
Yes.
So for gamma function, it's minus beta x, right?
Okay, sorry. This is a beta. And this is alpha minus 1, right? So if we have to calculate the mean value,
So that will be alpha by
Alpha
beta.
alpha upon beta, right? So here alpha is what? Alpha minus 1 equals to 12. So alpha equals to 30.
30.
300 plus 1 upon 20.
20. Exactly.
That will be around 0
0.04.
0.04.
Yes.
Okay. So it's fine. So here likelihood was also exponential, prior was also exponential. So you can, so whenever you see the questions also, most of the question will get converged to gamma, beta, some sort of things. Okay. You will not get the difficult questions also. So you'll be able to solve if you're getting the questions in Bayesian imager. Okay. We'll move to the third one.
Sir, can I have a doubt, sir?
Yeah, yeah.
So please show me that answer screen.
Okay, okay.
Sir, yes, sir. In the that's for now. That's here. Prostate density is proportional to lambda n
Yeah,
or
yeah.
yes. Sir, here, sir. Actually, how in the last 1 by 20 e to power minus lambda by 20.
Yeah.
Sir, here actually lambda value is 1 by 20. How can I write e to power minus lambda?
Where lambda value is 1 by 20?
Sir, sir, here we are taking it is Exponential follow is 1 by 20 pro. So here lambda is 1 by 20.
Yeah, I wrote here prior distribution is in the form of this one.
Yes,
1
sir.
upon
So
20, it is power minus lambda upon 20.
yes,
right?
sir. So yes, sir. My doubt is we have already written lambda is 1 by 20. Why we are putting lambda again here?
Actually, he's confused with the notations. So here he has considered lambda and x you can change.
This is not lambda. This is some sort of distribution.
You can even mark that as x.
Okay, this is not lambda. This is some sort of distribution. Okay, so this is and just that's why for the confusion only I told you in the starting. For the prior I just wrote here for the prior distribution. This is the distribution. Okay, 1 upon 20 it is power minus lambda upon 20. So here lambda we are not knowing. Lambda is what we have to estimate. Okay, are you getting my point?
Yeah.
The lambda, whatever you are like you are thinking, is not 1 upon 20.
Okay, so basically it's x we are denoting it as.
Where?
So for I think he is confused with the formula. So
yes, the formula actually is lambda into e to power minus lambda x.
yeah, that is for exponential lambda, right? So now
Yeah.
consider exponential x, say exponential x. So what will be the formula? X e to the power minus
lambda x.
lambda.
Okay,
No.
so you have
Yeah.
denoting.
Yeah.
Okay.
It's a donation, like whatever it's been here written. That's why in the starting I told you so that you should not get confused. That's why I've written in the starting itself. Because I was knowing many of you will get confused. That's why I wrote it. Okay, now it's fine.
Yes, sir, it's fine. I notation diffusion.
Yeah. So this is the third one. So here the marks of 10th class student of a school follows normal distribution. Means you're having a normal distribution with unknown mean and variance as 36. And marks of the sample value we have taken out the 15th student and the marks has been given like this. So now you have to find the Bayesian estimate or the posterior mean of mu value or the mean value, assuming the normal 70 is the mean and the 25 is the variance for the prior distribution. Now you have to calculate the Bayesian estimate. So basically there's a formula, simple formula. You can write it and you can calculate. So I've given you the hint also, or you can go through the basic approach also, but from that basic approach also you'll reach the same thing. Okay, and that has been discussed in the lecture also. So I'll wait for 5-7 minutes and then I'll try to solve this. So here also you just have to write your answer in till double digit, double decimal, 2 decimal. Okay. Or even you can write it in the form of like what you can say numerical value also without decimal also. Remove the decimal value. If you are getting 51.7, you can just write 51 also. So yeah, you can start solving this. So here the prior distribution you already know normal with mean as 70 and 25 as variance. And the sample values are this one. And the sample values has come from the normal distribution itself. So that you can write the likelihood also. But you don't have to write all those things because you already have the formula. Simple formula, basic, you can solve it. So only 17 has responded. Yeah, please quickly solve this one. This is not that like there is one simple formula that has been discussed in this lectures also. So you can try that one. Yeah, so 61 is correct. Like 61.87 is the exact correct value. So here, what is, I'll solve this now. So I've given the enough time, like more than 10 minutes. So I'll solve it now. So here it has been given, the distribution is all normal, right? With mu and what sigma square. So here, right, this has been given 36. And yeah, so mu is unknown. And the sample also has been taken out from a normal distribution itself. Normal with mean as 70 and variance as 50. What was that? Variance was 50, right?
25.
Okay. 25, right? So normal distribution is a conjugate, right? So posterior will also be a normal distribution. Okay, but whatever the Bayesian estimate, generally Bayesian mean, or you can say the posterior mean, will be what? X bar. Do you know the formula, anybody?
Yeah, X bar into N sigma naught square.
Right?
N sigma naught square plus sigma square.
Sigma square. So n sigma
Yeah.
naught square is this one, and this is mu naught, right?
Yeah.
Plus mu naught.
Mu naught and
Sigma square
sigma
divided and sigma naught square plus sigma square.
right? So all the values has been given. Only x bar you have to calculate. So x bar you can calculate 12,
It's 60.
right?
50,
So it's
60.
60, right? So the summation of all the xi will be 60. So now you can write it directly. So 60 into what? N is 15
Into 25
into 25 upon 15 into
20
25
plus
plus 36, 70 into
36 by the same.
6 by 15 into 25 upon 36, right? Yeah. So this you can write it 15, 25. So 60 upon 36 plus, oh, sorry. Oh, no, we can't do this.
60 upon 36.
We can't do this. It's in the summation, right? So now you can do the calculation part. So you'll get around 60, right? 60 point some 87.
87, yeah.
Right? So there was no, like, it's a simple formula that has came from the normal distribution. So whenever the prior will also be normal, and the likelihood means the sample has also came from the normal distribution. So you'll get also normal. So this is a conjugate, what you can say, distribution. Okay. So the normal will get in the end. From there, we'll be having the estimated mean value as this one. So this formula you can remember. Maybe you can get the question, like not this time, but in the final use you can get some sort of questions from here also. So if they have been given some sort of normal with not this big samples, some smaller sample values, so that you can calculate orally and then you can write it. So this is a simple formula x bar into n sigma s bar
So
upon n.
can we
Yeah.
expect this formula will be given in the exam?
Can you explain? So this has been discussed in the lecture. Okay.
No. What I'm asking in the exam, whether it will be
Okay,
provided in the formula section.
the formula for normal distribution will be given. I don't know if this one will be given or not.
Okay,
If
okay.
this will be given, then you can just. So I think so. This will be given, but I'm not sure about that.
Yeah, but this is not required for this quiz, right? So
This is not required for this quiz.
yeah.
Yeah. So we'll move to the fourth one. Yes. So this is the fourth one. 3 out of the last 10 candidates win a treasure hunt game. Okay. Previous record shows that the fraction of winners follows the beta distribution with the average of 40. Estimate the long-term fraction of winners of the treasure hunt game. So you can assume that beta is simply a your prior distribution. Okay. So the prior distribution has been given. Average is also given, like the mean value. So for the beta distribution, you already know the what you can say, the mean value. So from there you can calculate A, and then if you are having the beta distribution like the prior you have already have, so likelihood you can write it because 3 out of 10 last 10 candidates you not reserve. Okay, so you can assume one as a P and one as a, like winning the game as P and not winning as 1 minus P, and then you can write the you can write the likelihood also. You can multiply the prior and then you'll get the posterior. Okay, so this is a bit simple one. So yeah, so I'm giving you 7 minutes time to solve this and then we'll discuss it. So everybody is clear, right? Beta, the distribution with alpha as A and beta as 6. Average is 40 means
Yeah, the mean of beta is alpha upon alpha plus beta, right?
plus beta. Yeah. So that is 40. So you can get A from there and then you can write it. Yeah.
So excuse me, sir.
Yeah.
Sir, do we have to find the posterior mean here?
Yeah. Yeah.
Okay. So can you just explain this question once more?
See, here long-term fraction of winner, that means simply the probability that you have to calculate, okay, for the distribution, or you can say that you have to estimate the p-value, right, from the long-term fraction of winner means for that distribution, okay. But here it has been given the prior distribution is the beta distribution with alpha as A and beta as 6, right? So how generally you calculate the posterior or you estimate the posterior value? You just write the likelihood. With the likelihood you can take in a, like you can calculate likelihood or the probability that 3 out of last 10 candidates. That means what? If you just consider winning the game as p probability, like with p probability, the losing is 1 minus p. So 3 times he's winning the game means p to the power 3, right? And 1 minus p to the power 7 because 7 is losing the game. And you have already the prior distribution as beta in the form of beta distribution. You already have the average value. So you can estimate the value of p, right?
Yes, sir.
Are you getting the point? Yeah. So you can
Yes.
calculate. So till now only 16 people has responded. This question was pretty simple. Like beta was given, like the distribution for the prior distribution for the P was given as beta. So I'll solve this. So it's been like 5 to 7 minutes. So should I wait, or it's like you all have tried this one? Yeah, so the correct answer would be 0.35, I guess. Yeah. So I'll solve this. So you already have the prior distribution of P as what? Beta A comma 6, right? And what you can say, the mean value is what? A upon A plus 6, that is equal to 0.4. So A minus 0.4A equals to 0.24. 0.6A equals to 0.2.
So what will be 2.4?
0.4 is the fraction has been given, right?
Into 6, huh?
Where?
No, 0.24. Won't it be 2.4? Because 0.4 to 6.
What can you repeat the 0.
0.4 into 6 is 2.4?
Yes, sir. It's a cross multiplication.
Yes, sir. In the
It
right
is
side, in the right
2.4.
side, A minus 0.4A equals to 2.4, no?
Where?
Instead of 0.24, it's 2.4.
Right hand side, it is 2.4. It's not 0.4.
Multiplication, sir. 0.4 into 6 is equals to 2.4.
Yeah. So 2.4, here also 2.4 and 2.4 upon 0.6. So it's 4, right? So now you're having the beta with alpha as 4 and beta as 6, right? And you can write the posterior now. If we can just assume, what was that question? Where is that? Yeah. So 3 out of last 10 candidate wins. Okay. So you can just assume this, the probability as P of winning. So out of 10, 3 has won. So P to the power 3 into 1 minus P to the power 7, right? Has been 7 has lost. And with the beta also, generally, how would we write the beta as x to the power alpha minus 1, right? And B 1 minus x 1 minus x to the power beta minus 1, right? So we can write it here. P to the power alpha minus 1 is what? 3. And 1 minus P beta minus 1 is 5, right? So here it's in the form of P to the power 6 into 1 minus 7 to the power 12, right? So now we are having the beta with alpha as what? So this is equals to alpha minus 1 and this is equal to beta minus 1. So now we are having alpha as 7 and beta as 13. Okay. So now we can calculate the mean as alpha upon alpha plus beta. That is what? 7 upon 7 plus 13. That is 7 upon 20. That is approximately 0.35. Have you got the point? So we have the prior distribution in the form of beta. So for that prior, we can just write A upon A plus 6 equals to 0.4. From here, we can get A. Now we are having A, so we can get the distribution for this. And for the likelihood also, we can write it in this form. And prior is beta. So we'll get again the beta in the form of this alpha and this beta. And then we can calculate the posterior mean of this beta. So we'll be having 0.35 as the probability, right? So we have discussed till now 4 questions. So we'll move to the second last question of our today's session. So this is the solution. You can go through. We'll upload this one. Yeah. So this is the fifth A. Following frequency data shown in the shown is the number of patients. So number of patients arriving in an emergency room between 12 a.m. to 16. So this frequency, like for so generally for the two frequency, like for the 2 days between 12 a.m. to 6 a.m., there was no like patient in the emergency. There, like you can say, none of the patient has came, like for in the emergency room. For the 7 times, or you can say the 7 days, for all of the 7 days, only one patient came in that emergency room. For the 17 like frequency, or you can say the 17 days, or you can say the 17 number of times, 2 patients came. Similarly for 8 also, for 10 to 4. Okay. So now you have everything. Now you have to calculate the Poisson. You have to calculate first the parameter. Like find the parameter means you can consider the lambda you have to calculate here. So for the, if we are having some sort of what you can say, if the data has been given in some sort of frequency and number, how generally you calculate the mean value? You can say the lambda. You can calculate directly. There's a nothing in this question. You can directly, for this question at least, you should, everyone should answer. So here you don't have to do anything, like just have to calculate the mean. How generally you calculate the mean? You have the frequency value and value. Just have to multiply it like every time 2 into 0 plus 7 into 1 plus 17 into 2, 8 into 3. So every time you have to do this and just have to divide it with the number of frequency, right? So everybody has, whoever has given the answer is almost correct. But why only 13 people have solved? This was a pretty simple, like this is the most simplest question out of like we have discussed till now, the 5 question. So I'll solve it.
Yeah, I solved it, but the problem is the question is real because you said I found the mean. It's a sample mean, but the question is little difficult to understand. It says fit the data into Poisson distribution, right? That is little confusing.
Okay, you got confused with that.
Yeah, I have given the answer anyway because you told to find this lambda. Yeah, but the sentence is little. It says fit the data into because we are basically according to you we are finding the sample mean, right?
Yeah, I got the point.
But it says fit the data into Poisson. It is no connection with Poisson, so it is little confusing.
Okay, so this is a I am getting your point. So yeah, so but we have to calculate the mean, or you can say the lambda value itself. So this is a simple problem of Poisson distribution only. We generally talk about some sort of interval and then passing of some sort of patient or any other sort of examples, right? So yes, 2.78 is the correct one. So I'll just write it. I'll not solve the calculation part. So here is n. N is what? So 2 upon 7 upon 17 upon all those values. Here 0 into 2 plus 7 into 1 plus 34 plus 24 0, right? So we'll get 7 plus 34, 41,
139.
139 you will get here. And here you will get 50. So you'll get around 2.7, right? 8. Okay. So the next one is on the same, like you can say so the same datas are there. Now you have the lambda value, right? Oh, say I've given you the solution also. So now you have to calculate, find the approximate like 95% confidence interval using the normal approximation for the error distribution. So sample variance has been given, S square equals to 2.34. This will help you a lot to calculate. Now you have the lambda value. So what you can do, I'll give you the hint. You can just calculate the, you have to plot the, what you can say, the error distribution has been given as normal, right? So for the error, you can calculate first the, for this distribution, you calculate the mean value for this distribution, okay? And then a sample has been given, the variance has been given, S square, but yeah, so S square has been given, but your variance would be S square upon N. N has been given was, N was 50, right? So now you have everything. You are having the mean for this distribution, the sample variance for this distribution. For that, you have to calculate the 95, like you have to calculate those interval for which 95% of times that will fall in between that. Okay. First calculate the mean value, then the variance. Variance pretty simple, S square has been given and you already know, so S square upon N. So here n is equals to 50. So that you should remember. And you won't need anything else. So n equals to 50 here. So yeah, now we have to calculate the interval such that 95% of times the mean value will fall into that interval, right? So we can do this one. I'll solve it now. Till now only 15% has responded. Out of that, 11 has said correctly. The D is correct. A is not correct. D is correct, but both are almost. But yeah, so there may be some, I guess, calculation mistake, but it's fine. So I'll discuss this. So for that error distribution, you have the normal, okay? So the mean you can calculate, right? So mean is what? Expected value of E lambda minus lambda, that will be 0, right? And so we'll be having the normal with mean 0, and this as sigma square upon n. So we already have s square 2.34 upon 50, right? So now we'll be having some sort of distribution where this is the lambda. So lambda, this lambda plus some delta, and this is lambda minus delta. So this area is what? 95%. So what we have to calculate simply, the probability that the normal, this normal distribution of 0, 2.34 upon, that is equals to 0.0468. Okay, so the probability says that the normal of 0, 0.468 is less than delta, right? That we have to, it's been given as 0.95, right? So for this we have to calculate the delta, right? So this is simply probability of what? Between both the values, you can say the normal of 0, 0.68 from delta to minus delta, and this has been given also, right? Here it has been given as 0.42, so you can consider delta as 0.42. This is the one method you can solve with this if you have been given this hint, right? So you can, delta is what? 0.42, and lambda you already have 2.78. So this is what? 2.78 minus 42 and 2.78 plus 0.42. This is a one method, and you can also do, so here nobody is having problem, right? So you have the normal distribution with 0, s square upon n. You just have to calculate the probability of error such that less than delta, and this error is having distribution of 0, 0.0468, that is equal to 0.95, that is this area, right? And this generally you can write in this form, and that is equal to 0.95, and from that hint you got to know about this delta as 0.42. So from there you can directly write lambda minus delta or lambda plus delta. Have you got the point? Whoever was not able to solve this, right?
Yeah.
Yes.
Yeah. Or
Yes, sir.
Yeah. So one is this method, and you can also solve this question with. There was one method, I guess, was discussed earlier also. Probability that you can change this normal of 0, s square by n to normal of 0, 1, right? So there you can calculate the probability of z such that greater than some sort of what, mu minus mu cap or lambda minus lambda cap upon sigma by sigma n, right? And this lambda cap means you can write it alpha upon sigma by root n. For 95%, you already know this value is equals to 1.96. Maybe in the earlier, like in the earlier weeks and all, you have known. For this 95%, generally you generally get this value, this alpha as 1.96. That you can equate, and from there you'll get the alpha. So alpha equals to 1.96 into this is what sigma, or you can say s upon root n. S you can write s square upon n is some values. S square upon n was this value 0.0468. So you can write s as root of 0.0468 into root n. This got cancelled. So alpha you can calculate from here. Right, you can write it alpha minus this comma lambda. So this is also one method, but that was simpler one because hint was given there. And this is the basic approach that you already know from the last weekend.
Sir, excuse me, sir.
Yeah.
Sir, can you give a quick review of the first method?
First?
Yeah, first approach.
Okay. So the first approach was you already have the error distribution was in the form of normal with 0 as the mean, right? Because mean we have calculated expected value of lambda, mean is lambda minus lambda is 0, right? So mean is 0 for that error distribution, and for that the variance would be s square upon n because this is a sample. So s square already we have, so s square upon n is this one. So we have the error is in the form of normal of 0, 0.4680, right? Now we have to calculate what? You have to calculate the probability such that the normal mod of normal of 0, 0 or this error distribution should be less than some delta such that it's equals to 0.95, right? This area. This area is what? Lambda is the mean, and lambda minus delta, lambda plus delta, right? Okay. So this area you have to calculate. So this area you can write in the form of also normal of this 0, 0.0468 less than delta greater than minus delta. And this you have been given the hint also here. Right, see 0.042. This is what? Minus delta and minus delta. This is 0.95. So delta you already know. So from here itself you would have calculated. Delta has been given here directly. So lambda plus delta and lambda minus delta. Lambda you already have. So you can directly write lambda plus 0.42 is 3.20 and lambda minus 42 is 2.38. Okay.
So, sir, in these kind of questions, wherever the delta is given, we can easily calculate without using any calculation, without means going into that part, calculation part.
If the hint has been given, you can directly write it like this. If 95%.
So in quizzes also the hint would be given like this?
Yeah, because you can't calculate, right? They can't give the, if they are giving you the distribution seed, then they will not give, otherwise they'll give you.
Yeah, okay. And so all the formulas like relating to this ML estimator and everything for the particular distribution will be given?
Yeah, everything will be given. The formulas and all will be given.
Yeah, and so the formula step calculation, like which we are given marks on the basis of the steps used, that part will also be there or not?
That I'm not sure, but mostly it will be there. I guess maybe in the next session I'll tell you. Okay, but I'm not sure about that. But it will be given, I guess, because last exam was having that. This exam will also have. The questions and all has not finalized, so I have not seen the question. After watching that, I'll tell you whether it's like those sort of questions are there or not. But I'm pretty like 80 to 90% sure it will be there.
Okay.
Yeah.
Can you tell us that from where we got that value 1.96? Is it from Z table or?
Yeah, G table only we got. So maybe in last week or 8th or 7th week, we would have discussed that. Because I already like I'm having in the mind whenever this 95% is generally given, 1.96 we generally take that back. That's why I wrote directly. Otherwise, you can solve with this method also. But I think so in the last weeks there were so many questions where you would have taken those. Whenever you are changing the normal, some normal distribution to that standard normal distribution 0, 1, you generally take that consider that as 1.96. I guess I have solved those type of questions. That's why that is how I have remembered that.
Okay, actually I do check with the Z table, but this value was something different. That's why I'm asking.
What was the value?
Let me check it again. I don't remember that exactly.
That will be 1.96 only. I'm pretty sure. So the next question, till that time you can see that I'll show the last question of today's session. What happened? Yeah, so this is the last question of our today's session. So the outcome of on tossing a coin 15 times are this one, HT, whatever has been given. Let P be the probability of head. Previous record shows that. So this is also same type of question that we have discussed earlier. So the prior distribution we has been given as beta with 7 comma beta with the average of 70%. So you can calculate beta from there, and then you have been given the sample 15 value from from the distribution. So you can easily, I guess, calculate this. So this type of problem can be asked in the final exam. Okay, so not that a difficult question will be asked because it will be asked regarding the standard thing only, like beta, gamma, and for those also the formula would be given. So you just have to know ki whenever you are having this likelihood and prior as beta, so what sort of posterior will get, those sort of things you see. No. Yeah, so whoever was telling what is that value?
Yes, sir. Actually, it's reflecting 1.65 for the 95.95 as per the table.
G plot. Okay, I'll check it. But I don't know where I have seen 1.96. I guess the faculty also told 1.96, right? In the
That yes, sir. That's why exactly I'm checking that. Okay, I need to check with Z table, but in Z table, 0.95 reflecting at 1.65.
That
no,
is different from
T distribution. Yeah.
That's not.
Sorry.
I think that will be from minus infinity to the 1.65.
Yeah. Okay, yeah, correct. I guess that will be from minus infinity, because if you are considering one, this has 95, this will be 0.25 and this will be 0.25. So 1.96, you are telling what? 65.
Yeah, the 1.6 is a normal calculator. That's what's showing. But sir has given different.
No, but normal distribution, if we follow, then it will constant. It will give the same value at, right? Because Z table is made for normal distribution only, no?
No, but he has given value no for alpha by sigma by root n. So that's what he has given. This represent that. So that in that normal, that values are for alpha by sigma by root n. So I don't know that it's not the same as normal calculator. I think.
I'll check it once. 1.6.
I think there are there are two types of normal distribution. So which normal distribution you are following?
Stand for C.
Depend on that, you will get this.
Yeah. See, what
Some.
okay, you are considering from minus infinity. So that guy was saying correct. I've seen just now. I've seen the G distribution table. So that is considering from minus infinity to that 0.95. So you are considering that one, right? So you are thinking that one as column and one as row, right? So you can see the graph there. So that graph will represent from minus infinity to that G point. Okay, there it's showing at 95%. So you can check the distribution there. So the plot has been plotted. So wherever you are seeing the Z distribution, just see the plot for which plot it has been given.
Yes, sir. That is negative infinity to positive infinity. Exactly.
But we are considering for that border point, right? So in between that. Okay. Have you got the point?
So for that, do we have some another kind of Z table? For
See, for that, I would like in the last, that is how I remember 1.96. Just now I have seen the G table. Like I thought.
Exactly, sir. Actually, over here, you remember that value, so you solve with using that value. But if we don't know that value, then how to check that what is the value for that? So for that, we need to refer some Z table, no?
Yeah, so they will give you the, if they are asking that, they'll give you the values, whatever has been required to solve that question. So you should not worry about that. If you are saying, if you have, see, if they only give you the G table, okay, like from minus infinity to that point, so they'll not give you such type of question where you'll be requiring to calculate in between some sort of values, right? Are you getting my point? So they'll give you the hint. If they're asking to calculate G from minus alpha to plus alpha, so they'll give you the probability in between that. What's the probability for those? Okay, they'll not just give you the distribution so that we'll, because they have not, like what you can say, we have not taught you how to read the distribution table, right?
Right, right.
Yeah, so they'll not give. So don't worry about that.
Okay, sure, sir.
Yeah.
Thank you.
Vishal, just a quick question. Do we have till 11 weeks or is 12 week also there?
No, we have only 12, 11 week.
11 weeks, okay.
And from that 11th week also, I guess some portion are not compulsory. So from that to 11th week also. Yeah.
Okay.
So yeah, so this question you can calculate beta directly. So why only 9 people has responded? I guess beta you can calculate directly. You have the formula for that. Like you know the average value or the mean value for the beta distribution. That will be alpha upon alpha plus beta equals to 0.7. From there you can calculate beta. So here also you have the probability, like you can consider the p, that is the probability of head as p. So then the probability of getting tail is 1 minus p. So you can write the likelihood function. So that will also, after multiplying also you'll get a beta distribution. So you can directly write it. I don't think so there is any issue in this question. I'm giving you 1 more minute to solve this. So G distribution, I can find one more G distribution. There the values is from 0, okay, from 0 to some sort of value, Z value. there I can see 0.475 whenever I'm taking 1.96. That means that is considering only one side. So that is correct. So you need to see the G, like G distribution exact, like there can be two G distribution. One can be from minus infinity to that G point, and one can be from 0 to that G point. So from that 0 to the G point, if you are getting one from 1.96.475 as the percentage, so you can multiply directly by 2. So you'll get 95%. So you can just go to the Google and just see the G distribution. I can find here directly one from 0 to that G value. There you can directly see from 1.96 and then multiply by 2. You'll get at 95%. Or if you are watching from from minus infinity, 1.96 generally indicates 97.5%. So yeah, so I'll solve this last question. So the prior distribution was beta with 7 and beta, right? So you can directly write the expected value of x as what? Expected value of p at 7/7 plus beta equals to 0.7, right? 7 equals to 49 plus 0. 7 equals to 4.9 plus 0.7 beta. So beta will get what? 3. Okay. So the prior distribution you already have with beta 7,3. Likelihood you can write it. So the posterior will be what? Posterior will be, how many H are there? 1, 2, 3, 4, 5, 6, 7, 8, right? P to the power 8.
So why is E of beta 0.7?
It's been given, right? The average value.
Okay, 7.
Yeah.
Yes, sir.
So you have how many values were this? 8, 15, right? So now the P is what? If you are having beta with 7,3, then you can write it x upon 7 minus 1 and 1 minus x upon 3 minus 1, that is 2. So P to the power 6 into 1 minus P to the power 2, right? So you'll be having what? P to the power 14 and 1 minus P to the power 9. So this is also beta. The posterior mean is also in the form of beta with alpha as 15. And this has how much? 20, right? So you can calculate the posterior mean as alpha upon alpha plus beta, that is 15 upon 15 plus 10, that is 3 upon 5 is equals to 0.6, right?
Sir, could you go back from beta is equal to 3? I didn't understand what we did from there on. Like when we got beta is equal to 3, because 7 by 7 plus beta is equal to 0.7. After that, what did we do?
Okay, so we got this beta, right? We got this beta as 3. Okay, so prior distribution we know, prior distribution we already have. So the prior distribution is what? Beta distribution with 7,3, right?
Yes, sir.
So the posterior is what? Posterior is simply likelihood into prior. Right? Likelihood,
Yes,
how we can write? Likelihood, we can write the product of all the probabilities. Like for the head, what is the probability? P. For the tail, 1 minus P. Right? So how many times we got the head? 8 times. And how many times we got the tail? 7 times. Right? This is what has been given. Head, we are getting 1, 2, 3, 4, 5, 6, 7, 8 times. Right?
Yes, sir.
So 1 minus, like 8 times, 1 minus P is 7 times. So this is the likelihood, and the prior we have got as beta 7. So this will be what? Alpha minus 1. So this is 6.
6.
8 plus 6 is 14. But if you are having beta distribution with P x equals to the power 14, you can write it alpha equals to 15. And beta equals to what? 1 minus P to the power 7 here, and 1 minus P to the power how much? 2 here, right? So we have got 1 minus P to the power 9. That means beta equals to 9 plus 1, 10.
So we're subtracting 1 in both for both of them for in case of prior.
Prior, where? Here.
No, like for when you're multiplying P to the power 6 into P to 1 minus P to the power 2. There.
Yeah. So P is the probability of something happening. So not happening would be 1 minus P, right?
Yes, sir.
Yeah, that's why I'm writing P and 1 minus P.
You are multiplying them, right?
Yeah, we are multiplying. Likelihood into, generally we multiply.
No, like even in likelihood, P to the power 8 into 1 minus P to the power 7, right?
Yeah, we are multiplying the likelihood. Likelihood simply the probability of happening of this sample, like H, T, whatever it's there. So yeah. So we can directly write it like this, and then we'll get the beta distribution. So we can write in the form of alpha, this form, alpha equals to 15 and beta is 10. So from there we can calculate the posterior mean. So mean would be 15 upon alpha plus beta.
But why does alpha become 15 and beta become 10? It's like we had them as 7 and 3, right?
Yes, 7. No. See, I'll write it again correctly. See, I'll just show.
No, sir, we just need to add, no, after multiplication, in the multiplication.
Yeah, we're just adding. See, beta was what? P to the power?
6 into 1 minus P to the power 2.
What is that likelihood? In that likelihood, P to the power 8?
Into 1 minus 6, P to the power 7.
Right? So the P got added. So P to the power 14 into 1 minus P to the power 9. This is beta. So beta of what? Alpha, beta with alpha is 15 and the beta is 10.
Okay.
So beta, how we write the beta? X to the power. If we are having alpha and beta, we generally write it in the form of x to the power alpha minus 1. And beta to be 1 minus x to the power beta minus 1, right?
1 minus x, yes, 1 minus x to the power beta minus 1.
Yeah, so here we can equate this equals to 14. So alpha we got 15. And this is 9. So beta we are getting 10. Have you got the point?
Yes, sir.
Yeah. So alpha we got 15, beta 10. So, and now we can calculate alpha.
We are just adding 1. So then beta upon alpha, right? Or alpha upon alpha plus beta.
Alpha upon alpha plus beta. So we've got the answer. So yeah, that's it from like.
So 0.6, right? 3 by 5.
Yeah, 0.6.
Yes.
So that is said, like that's it from the today's session. And yeah, so you can give more focus on the 5th to 8th week content for that second quiz. And yeah, and if you're having any doubt, you can ask me. Like you can mostly post it on the discourse. You can tag me there. you can mail me.
And so from when we can expect some revision sessions regarding quiz 2?
Yeah, we are planning maybe next week. One session is with Andrew, sir. I guess
Okay.
on the 7th of March or 8th of March, like on the Monday. It's there on the Monday. Okay, so I guess it's on the Monday. Yeah, on the 7th Monday, you are having that. Okay, and yeah, so in that session, you can ask your doubt. And next week also, we'll be having the revision session. So one revision session is
That revision session is clashing with the maths exam, sir. Right?
maths exam.
Yeah. The
Okay.
mock test they are conducting in the same time as was stat class. It's
Okay.
overlapping by nearly more than half an
Which
hour.
one? Which one? It's overlapping. Which one? 10th or 11th one?
Fourth.
Which one?
On
Your
on
voice is
fourth.
not clear. Can some? Your voice is not clear.
On fourth evening.
I am not able to hear you. Like, can somebody else tell me? Like, when is your maths mock?
Maths mock is on 4th March.
Okay, 4th March we don't have any session, revision session.
So we have a session, no?
We have a session, but that is not for the revision. That is for the week 10.
Week 10, yeah.
Yeah.
But why should they really clash on that one?
Okay, so you don't want this 6 to 8.
Yeah, either you move the stat class by at least an hour earlier. Instead of
Okay.
6 to 8,
Okay,
you
so
can
I'll
bring it to 5 to 7.
tell them. Okay,
Yeah.
so I'll tell the team to maybe from 4 to 6 or something like that. Okay, just shift by 1 hour, right?
There was something on the 4 o'clock, 4 to 5. There is an English.
Okay.
English too. So 5 to 7 is probably an ideal time.
Okay, for that day I'll tell them to shift that. But if the time permits, but that is also a case. Many of the students will be having some other session also at 5 to 7.
Let me check my calendar, sir. Actually, I do have all the 4. So let me check that if it is clashing with someone else.
Not the math tool, stat tool.
Yeah, 5 to 6 is free actually. 4 to 5 we have English session, then 5 to 6 is free, and then from 6 to 8 is this stat session. So it might
So
get
6.
shuffled.
Okay, so 7 to 9 is fine, right?
Either 7 to 9 or 5 to
7 to
7.
9 you can't have it. Because mock test is between 7:30 to 8:30.
Okay. So 5 to 7, I guess that would be
5
good.
to 7 is better. Even if it overflows, we can take it. But the way what it
So I'll
is put
just
up now,
convey this
normal
message.
stat class.
Okay, I'll just convey this to 5 to 7.
Yeah, 5 to 7 is a better time.
Okay, I'll just convey this to the team. So I guess Mayur will be taking that session. I'll just convey. Okay.
Yeah.
If that will suit him, he'll tell the team to update
to
the
7.
calendar. If that doesn't suit him, so he'll take at the same time. Okay.
Okay.
I'll just convey this message to you.
Right. Thank you.
Excuse me, sir.
Yeah.
Sir, I have doubt in one activity question. It's from activity 9.5, question number 4.
Okay, I'll need to. So can you ask it on the discourse? Okay, I'll check it once. I'll just have to.
Sir, I'm not able to understand the question. If you can just guide me through the steps and what the question really expects us to. So it will be nice.
So I'll open it once. 9.5.
Yeah.
Yeah, which one?
So fourth question.
Let P represent the portion. Okay, suppose 10 times on samples of selection 3 are found to be defect. So now you're having beta with half, right?
Yes, sir.
So you can write the beta, you have the prior distribution.
Yes,
you
sir.
have the likelihood also with 10. So with 3 and 7, right?
So I have found that the likelihood it's proportional to p to the power 3, 1 minus p to the power 7. And the prior also I have got like p to the power minus 0.5 and 1 minus p to the power 0.5.
Okay, then what's the issue? You're not getting the correct answer.
So, but and this goes to a beta 3.5 by 8.5. Like what we need to find here? Do we need to find the posterior mean?
Yeah, you have to find the posterior mean of the final after multiplying the beta thing. So you have the beta. Yeah. So you have the beta with what was that 1/2 and 1/2. So now
Yes,
you are
sir.
having p to the power minus 1/2, 1 minus p to the power 1 minus 1/2, right?
Yes, sir.
This you have multiplied with how much? P to the power, what was that? 3 into 1 minus p to the power 7, right?
Yes, sir.
This you are having 2/3, sorry, p to the power, what is that? 2.5, right?
Yes, sir.
1 minus p to the power 6.5. Okay. Then you can
No, sir.
calculate.
Why it is, sir? Oh, okay, fine.
Alpha minus 1 equals to 2.5. Beta minus 1 equals to 6.5. So alpha you have 3.5 and beta is 7.5. So you are having 3.5 upon this summation 11. So this is the answer, 3.5 upon 11. How much you're getting? So
I was mistaking in between, but sir, I was not able to understand. Like, question is asking for unknown p, and we have to find the posterior mean here. So I thought like we have to find the. It's asking for the fraction, the p. So
okay.
but it's given here the fraction p like out of 10, 3 are defective. So I didn't understand like what exactly the question needs to get from us.
See, there was some sort of, you can just consider there's some sort of distribution. Out of that distribution, 10 items has been sampled. Okay. And out of that sample, 3 is defective. So you can consider P as a defective and non-defective as 1 minus P. Now you're having beta as a prior distribution prior to estimate unknown proportion of P of the defective. So proportion of P defective means you have to calculate the probability. That means you're having the prior distribution as beta. That means you can say the distribution, simple distribution of the P, okay, that you have to estimate as in the form of beta, half. And the other thing is in the form of the other, like you can say the likelihood you can calculate, you can write the likelihood from the sample simply, and then product will be beta, and that's it.
So because it happens to the question like wherever it's not directly given, we have to find the posterior mean. I find it difficult like what's question exactly wants from us.
See, here it is when you have to estimate the unknown parameter P, right? So,
yeah.
So you have, see, this is a simple case of Bayesian only because the prior has been given. Because in the other cases, for the moment of what you can say, the moment whenever you consider with the MLE or MME, you're having the prior as the some constant, right?
Yeah. So sir, here it's asking, we can understand like this also. Like here it is asking to estimate the unknown proportion P means we want an estimator like P hat, which has the parameter P. So can we like take also like how to find the things like this also like P hat or theta hat, something like that.
So P had, I'm not getting your point. Can you repeat that?
Yeah. So, sir, we are like, we are from the question, we are getting that estimate the unknown proportion P of defective items. This means we have to find the P hat kind of thing, which is the estimator. Like, so we have to find the posterior mean, which is P hat. So from this also we can understand. Like,
maybe sometimes generally what happens sometimes the problem with this sort of questions is the like whoever is preparing the question generally have the more idea what she's asking. Sometimes happen, but here there is not much of issue regarding the language. But yeah, many a times I also get confused with what has been asked. In many of the probability question, it happens generally. If I am preparing the question, I am knowing what I am asking. But whoever is reading the question can misinterpret what has been asked. But yeah, it's like many a times it happened. But here it has been given like you have to estimate the p value. Okay, so yeah.
So, sir, can we relate it to p hat? Like p hat is also a kind of posterior mean of some parameter p.
Yeah, that is simply p hat only, right?
Yeah.
Hmm.
So actually, these kind of questions are like here it is like if we just focus on the meaning of the question, it's asking from us to find the unknown proportion p of defective item. Means it's asking how much proportion of the total sample is defective. So like it's
Okay,
like
okay.
sticks
Yeah,
to my mind like that all only. So I got
okay, so you have just written 0.3. Yeah.
yeah, I thought it should be like that. And why it's asking such a simple question because it's given also.
No, no. So we have to estimate for the total distribution, right? So 0.3 would be the 0.3 would be the p hat for the sample, right?
Yeah.
Okay, but you have to estimate the p value for the distribution, right? That you can do with the help of three methods generally has been taught: MLE, or you can say the moment MME, and this one Bayesian estimation. But here it has been given as a prior beta, so you can do with the help of Bayesian. Okay.
So, sir, like somewhere it is like if it is given for the information is given to find the prior distribution, we can also find the likelihood if the distribution is clear to us. So, if in the question it's asking like estimate something, so we should use this Bayesian estimator.
Yeah,
thing.
yeah. You should use the Bayesian estimation only when you have been given the prior distribution of P in the form of some sort of distribution. It's not, if that is not constant, you should use this Bayesian. If that is constant, some sort of things, right? So see, one thing is the answer would be very much closer in each of the cases. That is the one thing. Bayesian estimation, mainly we use, that is what I have used. Many times I used in the algorithm, like base algorithm you will read in the ML, like machine learning algorithm, you will use one base algorithm. Generally, we used to see whether some sort of message is a spam or not spam. Like there can be many example of that base algorithm, but generally in the form of whenever we are we can say predicting, we are using this there is an algorithm based algorithm that generally we use in the classification problem. Like if we are having some sort of messages we are getting that can go in spam or not spam, that is spam or not spam. Okay, so in that form generally we use the base theorem. In that base theorem what happens, many times you generally that works on the messages what we are getting. Like for example, if you have got one mail that represents money, 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 money. Okay. So how that base algorithm generally works is they'll calculate the probability for each word. And on that basis, they'll calculate if the probability of getting some sort of good words, you can say the normal words is greater than the probability of getting the words like money, 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 and those sort of words. So then they'll classify that mail as a not spam. But many a times what happens, you don't have any words, right? So in that cases, base estimation sort of things can be helpful. So maybe you're not aware of that one. So, but I've just given you a simple perspective of that, how we generally use this Bayesian estimation in the further, you can say, algorithm and all. Maybe that is not, I guess, I'm not able to clarify, but yeah, so this is what generally we use, how this is how generally we use this estimation of base and all. In the further,
But sir, for the for the exam perspective, if we are looking, if we are in the question, if we are given with some prior to some distribution, and we
yeah,
are
yeah,
asking to estimate something which is related
yeah,
to the
then we should
parameter.
so you should use
சரி பிள்ளைங்க ஒரு அடை போட்டிருக்கேன் இங்க ஒரு குட்டி அடை present இருக்கு இதெல்லாம் ஒரு ஈஸியா.
So you have to use the Bayesian when you are having prior in the form of some sort of distribution, like union, beta, normal. Okay. So you just have to calculate with the help of Bayesian estimation. If you have been given,
And so this estimator term would be estimate the like something estimate. It would be
yeah,
given in the question. Then only we have to like go for the Bayesian estimator thing or posterior.
in the MLE also we generally estimate with the help of MLE, right? But here the prior thing will be given, the prior distribution of P or the whatever you have to estimate, prior distribution of that value or that unknown parameter will be given. So from there you can understand, right? You have to
If
use
prior
the
is given, then we have to get through Bayesian estimate.
Bayesian. Otherwise, you can calculate with the help of MLE also. The answer will be pretty much closer.
Yeah.
But if you will calculate the Bayesian, you will get some sort of exact thing. Okay, are you getting my point?
Yes, sir. So, but if prior is given, then why we'll go to such MLE?
Yeah, but MLE and see, most of the if they're asking MLE, they'll write directly, calculate with the help of MLE or with the help of yeah.
Okay, sir. Thank you.
So yeah, thank you. So I'll stop sharing. So just prepare for that. Maybe we'll meet again in the next week for the revision session. But yeah, till that time you can prepare that from the session for that quiz. But also 10th week, I guess, will be released, I guess. So you can go through that. And yeah, so thank you, everyone.
Thank you, sir.
Thank you, sir. Thank you very much.
Thank you, everyone.
Thank you. Thank you, sir.
Yeah.